Welcome back to Grade 10 Mathematical Literacy. Today we're going to look at nonlinear inverse proportion relationships. Well, first of all, what is a nonlinear relationship? By definition, it is described as one quantity A increases or decreases, there will be a varying increase or decrease in the other quantity. We saw an example of this in paying off a loan and the interest. As this increased, the months increased, less and less had to be paid off. Another one is throwing a ball into the air. We throw it up, it reaches its ultimate point and comes down again. So this is increasing and decreasing. So both of these are nonlinear relationships. They do not have a line graph, a straight line graph. Well, what is a nonlinear inverse relationship? Two quantities A and B are inversely proportional if as A increases, B decreases. There is a constant product between the variables in a linear relationship. There was a constant difference. Right, let's look at example 1. One of them, of course, his friends is trying to convince her to join a lift club to travel to work every day. The cost of petrol is about 500 Rand a month. This would be shared equally among all of the people in the lift club. They will travel per car. There are 5 of them in the car. So what would happen? If, of course, he went on her own, okay, so number of people she can take. If she went on her own, she would pay 500 Rand. What would happen if there were 2 of them in the car? Well, they would each pay half the petrol price. If there were 3 in the car, let's look and see what happens. If Nkosi went on her own, it cost her 500 Rand a month. If she found a friend to share the cost, it would be 250. If there were 3 of them, it would be 166.67 each. 4 of them would pay 125 Rand each, and 5 would pay 100 Rand each. Remember, this is inversely proportional because these values are increasing and these values here are decreasing. 500 Rand for one person. If they're 5, it is going to be 100 Rand each. So those values decrease. And it said that there is a constant product. Okay, how did we find that product? Well, 1 multiplied by 500 will give you 500. 2 multiplied by 250 will give you 500. 3 multiplied by 166.67, that's the rounded value, is 500. 4 multiplied by 500 will give you 500. So the product is constant. Remember, linear, we had a constant difference. So when I subtracted these two, I got the same value each time. But inverse proportion, if I multiply these two together, I must get the constant product. Let's look at what this looks like on a graph. Well, if Nkosi goes on her own, she has to pay 500 Rand. If she has a partner to go with her, each will pay 250. If there are 3 people, each would pay the 166 Rand 67. If there are 5 people, they would each pay 100 Rand. Note the relationship between the number of people, mention the horizontal axis, and the cost per person. Okay, the number of people in the car and the amount that each will have to pay for petrol. Mention those in your heading. Right, the graph, the first thing we notice is the graph decreases rapidly from there to there. In fact, the price is halved. But look, it is decreasing at a decreasing rate. Where does it intercept the axes? Well, it doesn't intercept the axes yet, and inverse proportion graphs never touch the axis, because if I plotted naught here following this pattern, it would mean that my graph is going to be somewhere up there, so naught people will pay 1,500 Rand for petrol, and that's absolutely ridiculous. You have to have at least one person for the petrol bill. Also, you can't have 5 or 10 or 15 people paying nothing. So if it intercepted the axis here, it would mean that 5, 10, 20 people are each paying nothing, which is also ridiculous. The next thing we need to ask ourselves, why is it a dotted line? Well, remember the test for that, can I get half a person? No, I can't. It is counted data, so it is discrete. We have a dotted line. Why does my graph end at 5? Why can't I have 50? Well, you cannot fit 50 people into the car. Another question that often pops up with these types of graphs, or any graphs, is describe the trend. When we describe the trend, we've got to include what's happening on both sets of axes. Okay, so we start from naught. As the people increase, what is happening to the price? Well, the price is decreasing. So the trend would be, as the number of people join the lift club, so the cost per person would decrease. We're now going to look at setting up an equation for a nonlinear inverse relationship. Well, remember there's a constant product, so what we will do each time, 1 multiplied by 500 will give us 500 Rand. 2 multiplied by 250 will give us 500 Rand. 3 multiplied by 166.67 will give us 500 Rand. 4 multiplied by 125 will also give 500 Rand. So now we introduce our variable, so we're going to say P multiplied by what will give us 500 Rand. So P multiplied by something must equal 500 Rand. Another way of looking at it, say I had a taxi that could fit 10 people in. If I had 10 people in the lift club, 10 multiplied by what must give us 500 Rand. So if I had to write that, we would be saying 10 multiplied by something must equal 500 Rand. 10 times 50 would give us 500 Rand. We know that, but when the 50, sorry, 50. But when the equations are more difficult, we need to have a method to do this. So we know 500 divided by 50 will equal 10. So the equation of an inverse relationship would be, you take your product, which is 500 Rand, 500 Rand divided by the number of people. And that would equal the cost. So the cost equals the total amount, 500 Rand. So 500 Rand divided by 1 would give 500 Rand. If I had 500 Rand divided by 4 people, each would pay 125. So that would be the equation for an inverse proportion relationship. That's all for today. I'd like you to do exercise 3 on page 64, numbers 1 and 2. Thank you.